Hello students, Ms. Slyman back again with our notes, part A, example 1. So in this case, like I said above, we use substitution to solve because in a system of equations, both of these are equal to y. Even if we use our f of x notation, f of x is just a replacement for y. So in this case, if I rewrite this as a system, so my system would look like y equals 3x plus 3. And y equals 3x squared plus x minus 5. Well, I can use substitution. I'm going to replace this y with the 3x plus y equivalent. So that's why it looks like this. So 3x plus 3 is 3x squared plus x minus 5. And of course I can use my calculator to help me see if they even intersect. So let's do that. In my y equals, one of them was 3x plus 3. And then we also had 3x squared plus x minus 5 plus x minus 5. I don't know what my window should be here, so I'm just going to do a zoom standard. So zoom standard is number 6. Oh, I didn't change my shading. There's my line. And there's my parabola, so I can see I've got two solutions. I'm going to come in here and I'm going to change my shading. Sorry about that. Good troubleshooting for you to see though. Right. So it looks to me like one solution is around between -1 and -2. My other solution up here looks like it's sort of between +1 and +2, so I'm going to find those. So calc, intersection, yes, that's my first curve. Yes, that's my second curve. It looked like it was sort of -1.2 maybe, as my guess. Really, it's -1 1/3. All right, so x is -1 1/3. And I also want my y value that corresponds to that. So I can see here that the y value is -1. And then my second one, let's see where that is. So again, I'm going to calc. Second calc. Intersect. First curve, second curve. And this time I need to guess somewhere over here. So I'm going to guess 1.3. And I get that the intersection is at 2, 9 exactly. So I'll pull this over to help us remember. So our second one was x is 2, y is 9. And we need both x and y because we wanted points of intersection. So really we should end up writing our solutions as points. Also, what I see with my calculator is because these numbers came out so nicely, that means I would have been easily able to solve this algebraically and with factoring. So if I simplify things, I'll have 3x squared minus 2x minus 5 equals 0. Oh, not minus 5, minus 8. Sorry, have to move that 3 over as well. And then this will factor. I already know it factors. So we're going to end up with, let's see, I think we're going to need 6 and 4. So 3 times -2 would make -6 plus 2 is going to make, plus 4, not 2. equals 0. So that means 3x plus 4 is 0, or x minus 2 is 0. So again, I'm going to get x equals negative 4/3. I'm going to get x equals 2. Those are my two x values. I also then need to plug them back in. So let's write this out. Negative 4/3, or x is 2. I know from up top that one of my functions was 3x plus 3. So let's go back and write that how it was written originally as f of x. So f of x, that's my line. I could plug these numbers into either the line or quadratic because that's where they're meeting. They're meeting, the line and the quadratic have the same values. So of course I'm going to pick the line because that's an easier one. F of negative 4/3. 3 times negative 4/3 is negative 4 plus 3 is negative 1, which is what we had said. And f of 2, 3 times 2 plus 3 is 9, which we had hoped as well. So we used our calculator as one way to solve, and we also used algebra as a second way to solve. And you can use either one. This type of problem might appear on a non-calculator paper, but if you've got your calculator, by all means use it.